This problem involves equivalency of two-dimensional shapes. I draw a diagonal from A to C. If the rectangle and the circle are equivalent, what is the circle's diameter to the nearest tenth? I have a 44-degree angle under the diagonal and I have an 8-unit side. In the circle, I have no information yet. But when we know that two-dimensional shapes are equivalent, we know that they have the same area. So the area of the circle will be equal to the area of the rectangle. And that means that pi r squared is equal to length times width. Now we have to do some trigonometry to get more information about a rectangle. I'm going to use the TOA formula. Tan of 44 is equal to opposite 8 over adjacent, which is my unknown. And this means that x is equal to 8 divided by tan of 44. And that is going to be equal to approximately 8.28. Now I'm writing down a rounded off value, but I still have the real value in my calculator, and that's what I'm going to use for further steps. I can now start filling in information into this equation. Pi r squared is equal to the length 8.28 times the width 8. These values are interchangeable. .28 times 8 is 66.27. This value is again rounded. And then r squared is going to be equal to 66.27 divided by pi. And that's going to be 21.096. And now I need the square root. The square root of 21.096 is 4.593. And again, these values are approximate because they are rounded off, but I am keeping the exact values in every step in my calculator. Final step, they did not ask us for the radius, they asked for the diameter. So I have to multiply my 4.593 by 2. And that gives me a diameter of 9.186, which rounded to the nearest tenth will be 9.2. I was not given a unit of measure, so I'm going to use units as my unit. This is how we deal with a problem where we are given two-dimensional shapes and told that they are equivalent. The key is to make the area of one shape equal to the area of the other, because that is using the concept of equivalence to solve the question.